Andrei, thanks for coming to visit us at Axus Technology here in Chandler, Arizona. Can you tell us a little bit about Halo Industries?
Sure, and it's a great pleasure. Thank you again for the invite. To give you some background on Halo Industries, we're a spin-out from Stanford University. We got started back in 2014, and we focus on laser-based technology solutions.
And what does Halo do in the laser with silicon carbide?
So we are very good at using lasers to essentially create and propagate a crack. So you take a single crack that starts off at the edge of the material, and you controllably propagate the tip of that crack through the material to essentially segment a piece of the material off. And the great benefit of this is that it's a very gentle process, and that you don't introduce, very many, stresses or strains in the material. You can create almost any shape that you're interested in with some constraints. But it's a much more performant process than anything that's available out there right now. And we believe that that's going to be the key to the future of the silicon carbide industry. And we feel that, especially the other laser technologies on the market struggle with a large segment of the materials available in silicon carbide, whereas we tend to do quite well.
How did you first hear about Axus Technology?
Yeah, it's really funny. I think about 4 years ago, we were looking for edge grinding solutions because we didn't have an edge grinder, and we had ordered one, but it was taking about, I think, 1.5 years to get it. And we were desperate for edge grinding solutions, and we saw that Axus did offer those, and that's kind of our first touch point.
What trends in the industry led you towards our products?
The two big trends that we see in the industry is the move to 200 millimeter, which really necessitates a lot of process improvements and cost improvements. We see a lot of quality issues with the traditional process for CMP, for example. The batch polishing process tends to cause a lot of scratches. It has a lot of limitations in terms of wafer thickness that you put into the process. So you have to bin wafers by thickness to put them into the CMP batch polishers. Whereas with a single wafer CMP, it doesn't really matter. You can adjust the process on the fly to handle different wafer thicknesses. You have many fewer scratches because you're running just 1 or 2 wafers on a single platen, so there's much less of a chance of an edge chip or some particle getting into the slurry and scratching the wafer, so you see much higher quality from a single wafer CMP. I think that's one of the things I really appreciate about Axus and the innovation kind of mindset that you have here at the company. You think about those problems because you do run the tools, you pay very close attention to the voice of the customer, and when you see something that's important, you work to put that into the roadmap as quickly as you can to add that feature such that it's available. Especially if a customer needs, kind of really clever new functionality for a certain process, you can tell me, it's going to take us 6 months and this is what we're doing, to get there. And we can work with you in the intermediate period to truly qualify the process with customers. We can send you a set of wafers. You can run, the R&D process that you have here so we can get initial data. All of that really helps set us up for success when we work with our partners.
That's great to hear. That's great to hear. Everybody thinks all this improvements are very straightforward, but they're not. It takes time to develop, and that's something that we're always doing here. So I'm glad it's benefiting you guys. Yeah.
And you have really creative engineers, and that's one of the things
yes,
I really appreciate.
Absolutely. We are
working with Dan Trojan and his team has been spectacular. I have a lot of respect for him. Yep. He's obviously, in my mind, the best engineer with respect to CMP in the world at this point. And having seen some of the innovations and the pace at which he pushes innovations has been a breath of fresh air, because that's what we try to do at Halo as well.
Right.
We're very much about, if something doesn't work, rip it apart, rebuild it, make it work better.
Right.
And we're very lucky in that the silicon carbide industry is very open to that kind of innovation right now. So I think working with Axus, it's just a spectacular team where it allows us to really quickly iterate, get many cycles of learning, and come up with solutions that are far ahead of anybody else.
So when you were researching CMP tools, we'll focus on that. What really made Axus stand out? Why you said, hey, this is the tool we want? Because I know you had many choices, but you ended up choosing Axus. I'm curious to know what really stood out.
As I said, we're one of the early adopters of the Capstone for silicon carbide.
Absolutely.
And when we were looking for a CMP solution about 3-ish years ago, we saw that it was very efficient, very easy to maintain, that you had really innovated on a couple of core elements that made it more productive from a wafers per hour standpoint, that really helped reduce consumable costs. And at the end of the day, when we kind of added up all the benefits of the Capstone and compared it with all the other suppliers, it was a pretty easy choice, to be honest.
Awesome. And did you see our ability to handle the silicon carbide wafers are thin and fragile? Did you see that ability really raising the bar?
It did, and we saw that you were processing even really unique substrates, whether it was gold polishing or glass polishing, very thin substrates. the tool set wasn't really developed for silicon carbide. It was developed for a much broader set of CMP process. And there, I think you struck gold with that because it was just naturally very adaptable to silicon carbide, and that it was already designed with those kind of stringent requirements in mind, such that when you ran silicon carbide, which is a bit touchy as a wafer, it didn't have as many issues, and you can really quickly adapt the process and the tool to silicon carbide, without spending a ton of time refactoring parts of it. So we saw that. We were very excited about it because obviously at Halo, silicon carbide is one material that we work on, but there are also lots of other things, lots of other materials and processes that we're working on laser solutions for. So we know that the Capstone can handle a lot more than just silicon carbide. And so as we get familiar with the Capstone, we can take it into different contexts, and take that experience and leverage it in other industries.
And since silicon carbide is probably the second hardest substance to diamond, to polish that is very, very difficult.
Yeah.
And it creates a lot of heat. And to get any kind of throughput and rate, you have to find a way to control that heat. And I think we've come up with a way, which what we call process temperature control. Do you see that really benefiting your process, your throughput?
Yeah, we believe that's caused the process to be very stable. So when we run the process, nonstop, hour by hour, we see, maybe in the beginning of the day, if you just start it up, maybe there's 1 or 2 wafers, we have to dial it in a little bit, but it's just rock solid after that. So the tool is up, it runs very stably. You compensate for the temperature in the room, and there are requirements, obviously, for the temperature in the room to not go beyond, certain bounds, but those are pretty loose requirements. And then when you have it dialed in, the temperature control on the tool works very effectively. And I know you're working on a number of innovations to continue, on that roadmap to make the tool even better, even more stable, to run even higher material removal rates. And I'm very excited to keep working on those with you.
How did our technology roadmap impact your decision?
That was a really good one, actually. So we saw that there was really no roadmap from Applied Materials. They had a tool, and there were small improvements here and there, but it was still the same basic tool. What we see with Axus is that you really care about the entire process. So you optimize, consumables, slurry. You add features that are important from a manufacturer standpoint, and that you look at the pain points that a manufacturer has, and you really work hard to adapt the tool, with each iteration to address those pain points. So, whether it's, new improvements to the carriers or new ways of delivering the slurry or different types of slurries or different types of pads or different materials for consumables like rings, all of those, improvements add up. And, since we're not the ones that have to go through and try to make those improvements on the tool, that really saves a lot of time on our end, and that we could just have a few dedicated folks on the team to CMP. And then we don't have to worry about, can we go out there and source, this better consumable or that better consumable. We can rely on Axus, work very closely with you because you're already working very hard on that. You care about that, and, you're spending a lot of effort trying to improve in that respect. So we really appreciate that particular part of the collaboration and of the fact that you have this roadmap for continuously improving the tool and getting to a cost that's really low, the lowest in the industry, and getting to a quality that's really the top-notch, top tier in the industry. And we see it. We see in the results that we get when we use the Capstone, and our customers see it as well when we send them wafers.
That's great to hear. That is one thing that we're very, very focused on, is continually getting our cost of ownership lower and competing.
Yeah.
So I'm glad to hear that that's paying off.
And obviously that's a challenge, right, with a single wafer process compared to batch process. But what we've seen in terms of the execution from Axus and from the Capstone tool is that just steadily, a curve that you're on, and you keep riding that curve, going lower and lower. And eventually, I believe it will be cheaper than even a batch polishing process, which is kind of the current process record for 150 millimeter silicon carbide right now.
So we talked a lot about the tools and how we work together. How would you say our collaboration, because our two companies, which I think we both consider sister companies, we work so closely together, and you were our first sale into silicon carbide. How do you see that collaboration helping Halo?
Yeah, that collaboration has just been really helpful for us because you've also opened our eyes to a lot of the, different processes that we can use at Halo. You've really kind of helped us with the process development, which has really accelerated our timelines for getting a lot of this stuff working well in high volume. Because it's not too difficult to get something working in low volume where there's a lot of hand holding. Mm-hmm. The hard part is getting it to run consistently day in, day out with minimal supervision. And I think that's where you've helped a lot. You've just really helped us understand the CMP process better. We came into it with a rough understanding of CMP, but not really having done CMP in high volume. So you've really taught us how to do CMP in many ways, and also taught us how to do wafer cleaning and a whole bunch of other parts of the process. So we really appreciate that, and we feel like that's really accelerated our timeline. And as we look forward, we see a lot more of that coming down the pipe. Obviously, the industry is moving quickly. Wafers are still fairly expensive, and we have to keep getting the cost down. A lot of the cost is in the wafering, and there's still a lot of work to do. But I'm confident that working together, we can come up with the right solutions, where we co-optimize the laser process and the post-processing to truly get, the price points for silicon carbide wafers to where it's truly ubiquitous in the power electronics industry. So there's still a ways to go, but I see how we can get there. I see a path. I
agree.
How we can walk down that path. There's challenges on the engineering side, and sometimes physics tells you can't do something,
right.
So you have to take a left turn.
Yep.
But I feel like between Axus and Halo, we have all the skill sets needed to truly solve all those problems.
That's great to hear. So in the overall experience working with Axus, what's probably the number one thing that impressed you both working with us and then on the equipment side?
I would say the most impressive thing about Axus is your openness and engineering innovation. So if you see that something is wrong, you really quickly come up with different solutions to try to address it. And we find that kind of engineering innovation very refreshing because it's how we think at Halo as well. So working very closely with you, with Dan, with the rest of the Axus team, it truly feels like we're not quite the same company, but we're very closely tied together, very complementary, right? Yeah. So we feel very good about the relationship. We feel like we can trust you. If we have a problem, we kind of bring it to you, and you will very quickly come up with a number of solutions that we can try out. We feel that the engineering team at Axus is quite strong, and they come up with very unique solutions to problems that they see in the industry. And at Halo, we benefit from that because we don't have to try to solve those problems ourselves. So we're very grateful, for the opportunity to work with Axus, that you're so close by. I can hop on a flight and be here an hour and a half or 2 hours to see the latest and greatest. Yep. And then we can rely on Axus, for a lot of the development work that we have had to do internally. We've had to allocate resources to it, come up with, potential solutions ourselves, try them, fail, iterate. Whereas we feel like we can rely on Axus to provide a lot of that. And that just helps in many different ways. But obviously for companies like ours, we're not as big as, say, a Wolfspeed or an Applied Materials. Right. That collaboration is critical for us making progress and becoming bigger players in the industry.
In that, do you see going forward more collaboration?
Oh, absolutely. I mean, we can't talk about the pipeline, the engineering roadmap that we have, because there's a lot of really cool secret stuff in there for now. But pretty soon, I think you'll be able to make some announcements, and I'm very excited.
Maybe on our next video, we could talk about all the cool stuff coming out.
I know. I'm pretty excited, to be honest. I think there's a lot of things that they're going to improve, and I think the customers will be very appreciative of it as well, because it's going to drive down costs, it's going to improve quality, and it's really going to make the silicon carbide industry, from a wafering perspective, much more mature in the coming years.
Our goal here is at least for CMP, is to make silicon carbide CMP as cost effective as silicon. And just keep continually working on driving that cost down, either through throughput, through different tool designs, consumables that we're testing. And that'll benefit all our customers. With that said, thanks for coming.
Thank you so much. It was a pleasure dropping by, as always.
It was good to see you.
Good to see you as well. So I'm looking forward to doing another update tour here to see the latest and greatest.
Great. Thank you. Thank you, everybody.
Thanks, everyone.